One-sided limits. There are 4 very important one-sided limits that you have to be familiar with. They all have to do with the graph 1 over x. So we've drawn the graph of 1 over x. First limit as x approaches infinity. So as our x value is getting bigger and bigger and bigger, what is the y value approaching? And the answer for that is 0. Approaching negative infinity. As the x value is getting larger in a negative direction, what is the y value doing? Again, approaching 0. As x gets close to 0 from, what's this all about? This means from the right-hand side, from a bigger value. So we're approaching 0 from a bigger value. So we're coming into 0 from the right-hand side. So that little plus sign just means from the right-hand side. And what is the y value doing? It's approaching infinity. This one, x is approaching 0 from the left-hand side. So the plus and the minus again just mean bigger or smaller. So coming to 0 from a value smaller than 0, or to the left of 0. So as we're getting closer and closer, our x value is getting closer and closer to 0. The x value is getting closer to 0 from the left. What's the y value doing? It's approaching negative infinity. So these are 4 very important limits. You must know them. So you have a couple of possibilities. You can choose to memorize them. You can choose to remember the graph, or you can think about them. So let's just think about them and see if that helps at all. 1 over infinity. Imagine I give you a test with an infinite number of questions. You get the first one right and nothing else. What's your average? Not very good. Essentially getting pretty darn close to 0. So that's why 1 over an enormous number is 0. What happens with this one? 1 over, again, it's an enormous number. It just happens to be negative this time. When you divide by an enormous number, you don't get very much. So 1 over minus infinity is getting close to 0. What happens when you divide by a small number? So a small number that we could divide by, let's say 1 over a million. 1 over a million is not a very big number. So 1, we're dividing by a very small number that happens to be positive. And when you divide by a fraction, how do we work that out? 1 over a million. We'd end up multiplying by the reciprocal. Oh, and that makes a very big number, doesn't it? And you can imagine, as we get smaller and smaller, we just add more zeros, so this number gets bigger and bigger. So what you want to keep in your mind is when you divide by a tiny number, you end up getting a large one. When you divide by a tiny number, you end up getting a large one. If you're still in doubt about that, you can take it on your calculator. Try dividing 1 by a very small number, 0.000, put as many of those in as you can, 1. That's essentially the same thing we're doing here, and you should find you get a big number. Okay, let's try this one. 1 divided by a tiny number, and if we're less than 0, that would be negative, wouldn't it? So 1 divided by a tiny negative number. Can you see what's going to happen? We know that when we divide by a tiny number, we get a very big one. And if we divide it by a tiny negative number, we'd end up with a big negative number. So that's where the negative infinity comes from. So we get 1 times a million, and it would happen to be negative because of that. So again, we must know these limits. You can choose to memorize them, get them from the graph, or understand them. But you have to know them. 1 over infinity, approaching 0. 1 over a very large number gives you not very much. Approaching negative infinity, we're approaching 0. 1 over an enormous number that's negative, still 0. Approaching 0 from the right-hand side, graph is going to infinity. When you divide by a tiny number, you get a big one. Approaching 0 from the left-hand side, we're going to negative infinity. When you divide by a tiny number, you get a big one. When you divide by a tiny number that happens to be negative, you get a negative big number. Now again, be just a little careful with this. We're saying the left of 0. That's why this is negative. That just means left. And it's only when you're on the left of 0 that you can think of that as a negative. Okay, let's try some limits. We'll approach infinity, so 5 over infinity. There's my infinite test you're writing. You get 5 right. There's still an infinite number. What's your average? Not very good. If you want to think about this from the graph, 5 over x is pretty much the same shape as 1 over x. As you approach infinity, what's your y value approaching? This one. If we plug in infinity, 2 times infinity squared plus infinity, that's infinity. 3 times infinity squared plus 1, that's infinity. That's another indeterminate form. So 0 over 0 was our first indeterminate form. Infinity over infinity is the next one. Again, it tells us we have not yet determined the answer, and we need a method for dealing with infinity. And here's one that works a lot when you see fractions. We're going to divide by the highest power of x from the denominator. So what is your highest power of x in your denominator? Looks like x squared to me. There's nothing bigger. So we're going to divide every single term by x squared. So the 2x squared divided by x squared, 1 divided by x squared, 3x squared divided by x squared, 1 divided by x squared. Simplify as much as you can, and then evaluate your limit. We're plugging in infinity. What is 1 over an enormous number? That goes to 0. 1 over an enormous number. That goes to 0. So our final answer is 2 over 3. Now, be very careful. This method of dividing by the highest power of x from the denominator works when you approach infinity or negative infinity. It does not work if you're approaching 2 or 5 or 7. And the reason for that is right here. Like imagine we were approaching 1 instead of infinity. That doesn't go to 0, does it? So it's only when you're approaching infinity that this is useful. So please keep that in mind. Okay. Approaching negative infinity, here's a fraction. I think I'd be tempted to divide by the highest power of x again. So the highest power of x again is x squared. So we'll divide everything by x squared. Simplify as much as we can. This one, if we take an x squared out, we'll be left with an x. So that's what we're left with. 1 over an enormous number that's negative. 1 over an enormous number is 0. Doesn't matter if it's positive or negative. 5 over an enormous number, that's also 0. So our limit, we're getting x over 2. And when you plug in minus infinity for x, you get minus infinity. So if you're unsure of what just happened there, we were left with x over 2. We were doing the limit as x approaches negative infinity. So we're approaching a very large negative number. When you divide by 2, it's still a very large negative number. Okay. 0 from the right. Let's plug in our limit. When you multiply 5 by 0, you get 0. But we have to check, are we slightly positive or slightly negative? That should remain positive, shouldn't it? 8 divided by a tiny number. What happens when you divide by a tiny number? You get a very large one, and it was positive, so you get a very large positive number. If you're unsure of what just happened again, when you divide by tiny numbers, you get very large numbers. So as the limit goes up here, getting closer and closer to 0 from the right-hand side, we're going to infinity. 2 more. These will be challenging. Let's see what we can do. Approaching 5 from the left. 5 plus 3, that's 8. We don't really need to worry about the slightly smaller, slightly bigger in the top because it really doesn't change anything. It's in the bottom where you've got to be careful. So 5 minus 5, that's going to be 0. But is it slightly bigger or slightly smaller than 0? So 5 minus means a little bit smaller than 5. So 4.9999999. When you subtract 5, you're getting very close to 0, but are you positive or negative? I would say negative. So again, what happened there? 5 from the left is a number like 4.9999999. So we're just a little bit smaller than 5. When you subtract 5, you're going to be very, very close to 0. But you're going to be smaller than 0. So 0 minus. 8 divided by a tiny number, that gives us a very large one. And it happens to be negative, so we get a large negative. If you understood that, you should be able to do this one on your own. So feel free to try that. If anyone's really stuck on this, going, I'm not getting this at all, you can try it on your calculator. Take a number slightly smaller than 5, like 4.99999, add 3. You're going to get a number just below 8. And again, it doesn't really matter in the numerator, so we might as well call it 8. Take 4.9999999 in your calculator, subtract 5, and you'll see you get a tiny number that happens to be negative. Divide 8 by that number, and you get a very large number that's negative. So the calculator can help you if you're having trouble understanding this. Okay, let's try this one. Oh, I was going to say the other thing that might help you is a graph. So 8 divided by a small number that happens to be negative. So again, we're just looking at the 1 over x graph and remembering what happens as we approach 0 from the left. So for those who need the graph, feel free to draw that to help you. Okay, this one. Putting in 5 from the right. 5 plus 3, we can call that 8. 5 minus 5, 0. Is it 0 plus or 0 minus? Slightly bigger than 5. Number like 5.0001. When you subtract 5, it should still be positive. What happens when you divide 8 by a tiny number that happens to be positive? You get a very large one, and it's also positive. For those who need the graph, as you approach 0 from the right-hand side, getting closer and closer to an x value of 0, what's your y value doing? You're going to infinity. Okay, today's exercise. Some of the questions will involve one-sided limits. Others are just practicing what we did the other day. So again, this means look at the graph from the right-hand side. This means look at the graph from the left-hand side. Should be an interesting day for you.